Welcome to another episode of Hardware Lens. In today's video, we are going to be installing the direct die plate on our Intel 10900K CPU that we just delidded in the last video. We'll be installing the direct die plate onto our motherboard and then mounting our heatsink or our water block to it. We're using the Arctic Cooling Liquid Freezer 2 280mm CPU cooler. It's a great CPU cooler. It's my favorite AIO cooler to use. It's got a very thick radiator, thicker cooling tubes, and it's just about the best performing AIO that you can get. And it's available right around $100. They're coming back in stock now. I got one on Amazon the other day, and there is a link to that cooler in the description. We'll be comparing the temps before and after. So with the CPU, with the IHS on, we'll be running 2 minutes of Prime 95 and recording the temperatures. Then we'll be running the same test with the cooler directly on the CPU die, and we'll be comparing the test and making the determination to see if this is really worth all the trouble and risk or not. So stay tuned and watch the end of the video where we compare the results. Okay, so the next thing we're going to do is remove the stock CPU retention plate. There's 3 star screws holding it in place. Okay, and there it goes. So the kit comes with new direct die kit. This is the direct die kit for 10th gen Intel CPUs. And as you can see, it sits here where the old plate was. Holds the CPU down. And it comes with this little plastic gasket, I'll call it, I guess. So for this to work, you need to have the CPU in place. And give it one more quick cleaning with acetone before we drop it in. Make sure there's no fingerprints on it or anything else. The acetone will remove all of that. Okay, so we got our nice clean CPU here. Line up the pin as we do. Make sure the contacts are nice and clean on the bottom. Look good. Okay, then we'll install our direct die plate. And hopefully our CPU cooler will... Oh, that was the wrong screw. That's the... I used the wrong screw here. Okay, so it comes with 3 new screws. The heads fit into the die kit, so we'll use their screws that are included. And the little socket that they give you does work with these screws. And make sure we torque them down evenly.
Felt a little resistance on that one. Want to make sure we're not stripping anything. Okay, we'll make it reasonably tight. Remember those hold down plates are pretty tight. Okay. We're going to do a quick test. Before we tighten everything down, I'm going to put a little dab of thermal paste on there and put the CPU cooler in place and make sure it's contacting evenly. Okay, so we're using Thermal Grizzly Conduct-A-Not for this CPU, just as we were before, and there's a link to that in the description as well. This isn't going to be the final application. I'm just going to put a dab here. I want to make sure that we have contact. Okay, so let's just sit our CPU water block down. Press it down, it's fully in place. And look at that. No contact. So we're going to need to use different standoffs for this. It's designed to be used with the stock IHS, and obviously we don't have that. It's pretty thick. So we're going to need to take up that clearance. Okay, so with the Liquid Freezer 2 cooler that we're using, there's no way to get the water block to contact the die directly using everything they give you without making a slight change here. In the kit, the Rockit Cool kit unfortunately doesn't come with a whole lot to help either. It would have been nice if they included some shorter standoffs or something to maybe work with some of the other water blocks out there, but they don't give you much to help. Okay guys, so I think I finally found somewhat of a solution here. What I decided to do, I've got this kit here that I got off Amazon. It's got an assortment of different PC building hardware, and what I decided to do is I took one of these motherboard standoffs and two washers, and that gets us direct contact with the CPU using the water block. The only problem is it's actually a little bit too low, so you'll need a long enough screw to go down in there, and you won't have the stability or the safety net because you're going to be putting a lot more pressure on the die now. But it's really no different than direct die cooling a GPU with a water block, and you do have the protection of the direct die plate itself. So let's go ahead and install this and see how it works. And when you apply thermal paste to a direct die, you just want to make sure that it's on there evenly. You don't want to leave any open spaces. You don't want air pockets getting in there, or else you'll have hot spots. So it's better to put a little more than not enough. And we're using the non-conductive thermal paste from Thermal Grizzly here, so we're not too worried about it. Okay, so I got it tightened down now. The only thing I had long enough was another standoff. So I got standoffs going into standoffs here, and tried my best to make it even. Don't go crazy on it. You don't want to crack that die. So I just tightened it somewhat tight, finger tight, and we'll check it out. We'll see if there's any hot spots. Okay, so a little bit of an update here. As you can see, I've changed the mounting screws for the water block. We had a little bit of an issue when I first tested this out, the way I had shown in the previous clip. It was the temps were pretty bad, so I knew something was up. seems like there was not enough thermal paste, and the water block didn't have enough downforce on the die itself. So what I did is I removed those standoffs, and I actually had a screw and spring setup that was attached to an old heatsink from an 1156 socket 1156 CPU, and that actually had the perfect standoff depth. So I went ahead and used that and screwed it into the back plate that I had, and it seemed to work perfectly. I was able to get really nice downforce on the water block, and even tightening. It felt very even when I was screwing it in, and we've got much better temps now that we'll show you in the next clip when we go over the results and the comparison.
In this test, we're running Prime 95 with 20 threads and AVX disabled on our overclocked 10900K. We're running the 10900K at 5.2 gigahertz with a die sense voltage of 1.385, and this CPU pulls anywhere from 150 to 200 amps while we're running Prime. So there's a whole lot of current going through there, generating tons of heat. So as you can see from the first clip, once we start the test, the CPU package temperature quickly hits 100 degrees and then starts throttling. Normally they throttle at 105, but I've got mine set to throttle a little bit lower just for safety. So we throttle immediately when we start the test. So I don't know how hot it actually would have gotten if it had the chance. It just would have went crazy, I'm sure. So pretty bad temps there at that speed. Now with the direct die, you can see when we start, temps go up initially much slower. They start out in the high 80s instead of immediately hitting 100 degrees, and they climb slowly throughout the test. And we hit a maximum CPU package temperature of 97, although it was mostly around 96. The 97 was just for a brief moment, and the average was 94. So we went from a 101 degree average package temperature down to 94 at the end of the test here. So that's a pretty good improvement, I'd say, from direct die cooling the CPU, because again we don't know how hot it actually would have gotten if it had the chance, but it really didn't throttle. One core throttled, core number 6 throttled for just a second, but the rest of the cores did not throttle under this quick 2-minute test here. So there's definitely a substantial improvement, and it makes sense because with that CPU with the 10 cores on that die, on that small little strip of silicon, when you're pushing that much current through it, it just can't remove the heat fast enough with a heat spreader at those kind of overclocks. It's just no way for the heat to transfer quick enough, so the die just roasts under there. But with the cool water block sitting directly on the die, it definitely makes a big difference and pulls a lot more heat from the die a lot more efficiently. So pretty interesting results there. I hope you enjoyed this video. If you did, let us know in the comments and give us a like and subscribe to our channel. Thanks, and see you next time.